projects. In this video, we are going to explain about the project, which is DFFMD, which is a deepfake face mark dataset for infectious disease era with the deepfake detection algorithms. Introduction of the project. The rapid growth of computer-generated editing programs has facilitated the synthesis and modification of media content, ushering in an era where the creation of fake videos and audio, commonly known as deepfake, and it has become more accessible than ever. The ease of creating deepfakes has led to a surge in the potential for misinformation, especially with the malicious spread of fake news and dangerous content. Deepfake technology utilizes deep learning to manipulate videos, alter facial features, and even synthesize convincing speech, posing a significant threat to the spread of false or harmful information. Since 2017, the research community has been actively engaged in developing techniques to detect deepfake using machine learning. Various studies have approached the challenge from different perspectives, including analyzing facial features, focusing on specific regions such as eyes and lips, and creating new deep learning architectures. The availability of free and open source deepfake tools such as FaceSwap GAN, DeepFace Lab, and Deepfaker has contributed to the widespread use of this technology. These tools enable the swapping of a source person's face with the target face, producing videos that are notably challenging for humans to distinguish between real and fake. Given the difficulty in visually discerning between authentic and manipulated content, the development of digital forensic machine learning models and algorithms for detecting deepfakes is more crucial than ever for ensuring digital security. The introduction of face masks during the COVID-19 pandemic has further complicated detection, leading to decline in the accuracy and motivating the proposed study to address these challenges. Objective of the project. The project aims to propose and implement an advanced deepfake detection model based on a novel architecture which is Inception ResNet v2. This model incorporates pre-processing stages, feature-based techniques, residual connections, and batch normalization to enhance the accuracy of detecting deepfakes, particularly those involving face masks. With the widespread use of face masks during the infectious disease outbreak, the project specifically targets the challenges introduced by obstructed facial features. The objective is to develop a detection model that can accurately identify deepfakes even when facial details are partially obscured by masks. The project aims to establish a benchmark for deepfake detection accuracy, particularly in the presence of face masks, by combining the performance of proposed model with the existing state-of-the-art methods, achieving an significant higher accuracy, demonstrating the effectiveness of the novel Inception ResNet v2 architecture. The aim of the project is to set the stage for future research endeavors by suggesting the need for subsequent experimental work to further enhance the detection of deepfakes with the face masks. This objective emphasizes the ongoing nature of the research, encouraging continuous improvement and innovation in the field of deepfake detection technology. To implement this project, we need software and hardware requirements. Software requirements are application of Anaconda, primary language of Python, front-end framework of Flask, back-end framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements are operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. To implement this project, we have designed various steps in the flow of work. The first step is importing the packages. This module involves importing necessary libraries and packages that are required for the project. We imported NumPy, Pandas, OpenCV for image processing, Seaborn and Matplotlib for visualization, sklearn for machine learning, TensorFlow for deep learning. Importing deepfake dataset. This module involves loading the dataset containing deepfake videos, which is a pivotal step for subsequent model training. Exploratory data analysis. The dataset structures and characteristics are explored in this step. Tasks include converting videos into frames, which is breaking down videos into individual frames for image-based analysis, image reshaping, which is ensuring all images having consistent dimensions for model compatibility, image augmentation, introducing variations in the dataset to improve model generalization. The next step is data visualization. This module involves creating visual representations such as graphs and histograms to gain insights into the distribution and characteristics of the dataset. Building the model. In this step, the architecture of the deepfake detection model is defined. Layers, activation functions, and other parameters are configured. Training the model. This module involves providing labeled data to the model for learning patterns indicative for deepfakes. The model undergoes training to enhance its ability to make accurate predictions. The next step is Flask framework with SQLite for sign up and sign in. This step implements a web application using Flask, which is a microweb framework coupled with SQLite for user authentication, which is sign up and sign in. This allows users to interact with the model through a web interface. The next step is user gives input. This module involves allowing the users to input the data, such as videos, that will be processed by the model for deepfake detection. The next step is pre-processing and prediction. In this step, the user input the data, which is user's input data is pre-processed to ensure compatibility with the trained model. The model is then used to predict whether the input contains deepfake content. Final outcome is displayed. This module involves displaying the results of deepfake detection to the user, indicating the likelihood of deepfake presence or providing a binary classification which is real or fake. Now we will know what are the algorithms used in the project. The first algorithm is Inception ResNet V2. It is a cutting-edge deep learning neural network architecture that seamlessly combines the strengths of Inception and ResNet architectures. It employs multi-scale convolutional filters through Inception modules to capture features at various levels of abstraction, and its integration of residual connections addresses the challenges in training very deep networks. With the global average pooling and batch normalization, Inception ResNet V2 excels in image classification tasks, making it suitable for intricate pattern recognition in the applications like deepfake detection. Inception ResNet V2 is chosen for its ability to capture intricate features at different levels of abstraction. The combination of Inception modules and ResNet residual connections makes it suitable for detecting complex patterns in images, which is crucial for deepfake detection. The next algorithm is VGG19. VGG is Visual Group of Geometry 19. It is a deep convolutional neural network known for its simplicity and effectiveness, belonging to the visual geometry group series of the models with 19 layers. It maintains a uniform architecture utilizing 3 into 3 convolutional filters and stacked layers of convolutional and max pooling for hierarchical feature extraction. VGG19's straightforward design contributes to the ease of understanding, making it popular choice for image classification tasks including deepfake detection, where strong feature extraction is essential. VGG19 is chosen for its simplicity and strong performance in image recognition tasks. It provides a balance between model complexity and interpretability, making it suitable for deepfake detection where robust feature extraction is essential. The next algorithm is CNN, which is convolutional neural network. A convolutional neural network is a specialized deep neural network architecture designed for computer vision tasks, particularly in image processing. It employs convolutional layers with learnable filters for spatial hierarchies, pooling layers for downsampling, and fully connected layers for making predictions based on learned features. CNNs are fundamental in computer vision, and in the context of deepfake detection, they can excel at automatically learning and extracting features from images, enabling effective pattern recognition. As an extension, we applied an ensemble method that combines the prediction of multiple individual models to produce a more robust and accurate final prediction. Also, as an extension, we built front-end using Flask for user testing with the user authentication. We evaluated the project using different performance metrics, which are accuracy, precision, recall, and F1 score. So here we have comparison graphs for all those metrics. This is accuracy comparison graph. Here on x-axis, we have individual algorithm names, and on y-axis, we have accuracy score. Accuracy is a measure of the overall correctness of the model. It calculates the ratio of correctly predicted instances to the total number of instances. This is precision score comparison graph. Here on x-axis, we have algorithm names, and on y-axis, we have precision score. Precision is the ratio of correctly predicted positive observations to the total predicted positives. It evaluates the accuracy of positive predictions. This is recall comparison graph. Here on x-axis, we have algorithm names, and on y-axis, we have recall score. Recall measures the ability of the model to capture all relevant instances. It is the ratio of correctly predicted positive observations to the total actual positives. This is F1 score comparison graph. F1 score is the harmonic mean of precision and recall. It provides a balance between precision and recall, especially when there is an Imbalance in class distribution. To execute the project, first we need to open the code folder which contains source code files. This is the code folder of the project. This is the dataset folder in which we have two classes which is fake and real. In this we have videos and we use these videos for training the algorithms. This is the static folder. This folder consists of file related to CSS, JavaScript and Bootstrap. This is the templates folder. This folder contains all the HTML pages used in the project. It includes files like index.html, about.html, etc., which represent different pages of the website. This is the app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. And this is the models folder, which contain the algorithm information and that will be loaded into the project code during runtime. This is the notebook file, which is the notebook.ipynb file. This is a Jupyter notebook file, which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. This is the signup.db file. This file is a database file used to store the user information. Now we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we need to open the Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path and then click on enter. By this, current directory will change to the code folder's path. Here we need to type the command python space app.py and then click on enter. This will compile app.py file and it will execute a Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which will be the local host and the port unless configured differently. This is the local host and this is the port. Now we need to copy this local link provided by the framework and paste it in any web browser. I'm copying the link. I prefer Google Chrome, so I'll paste it in that. Here we need to paste the link and then click on enter. This is the web page of the project, which is displayed in the browser, and this web page is built by using the Flask framework. Here we can see two links which are sign up and sign in. First, we need to sign up, so click on sign up. If you're registering newly, we have to fill in all these details. I have already registered, I have an account, so we'll directly sign in. So click on sign in. Here we need to provide the username and the password. So I'm giving my username and the password. And now click on submit. We have logged in successfully and we are redirected to prediction page. Here we can see a choose file button. We need to click on that to upload the videos. So click on choose file button. From the folder, I'm selecting the first video. Now click on open and click on upload. So here we got the prediction that for the given input, it is detected as fake, which means the video is deepfake. Now we will try with the other video. Click on try again. Click on choose file. And now I'm selecting the fourth video. And now click on open and click on upload. So here we got the prediction as the input is real, which is the input video is real. Now we will upload the other video and see what will be predicted. Click on try again. Click on choose file. I'm uploading the second video. Click on open and now click on upload. So here we got the prediction as for the given input video, it has detected as fake. Now click on logout. Similarly, we can upload the other videos and can check whether it is deepfake or not. Conclusion of the project. Through the utilization of advanced deep learning architectures such as Inception ResNet V2, VGG19 and CNN, the project achieves high accuracy in detecting deepfakes, showcasing the effectiveness of the proposed models. Considering the challenges introduced by the widespread use of face masks during the infectious disease outbreak, the project focused on deepfake face mask detection and novel pre-processing techniques demonstrates a proactive approach to adapting deepfake detection to real-world scenarios. Integration of the Flask framework with SQLite for user sign-up and sign-in enhances user experience, providing a secure and intuitive web interface for users to interact with the deepfake detection system. The project lays the groundwork for future research by proposing subsequent experiment work aimed at further increasing the accuracy of deepfake detection, acknowledging the evolving nature of deepfake technology and the continuous need for improvement detection capabilities. By successfully addressing the challenges posed by deepfakes, particularly in the context of COVID-19 pandemic and face mask usage, the project contributes to the advancement of digital security, providing a robust solution to mitigate the risk associated with the malicious use of synthetic media.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.